Welcome to our lecture on color. We're going to start off with some basics, some terms to know. First of all, there are two basic approaches to color systems, the additive and the subtractive, and we will be working with the subtractive system. That's the system which explains how pigments and other colorants mix to create the wide range of colors that we get from our three primaries, which are blue, red, and yellow in the subtractive system. The additive system is a system that you may use if you ever work with, say, theater lighting or lighting design in general. It works by adding various wavelengths of pure light to achieve the colors. Since the subtractive system is much more familiar to most of us, and all the principles of color theory are the same for both systems except how the colors are mixed from primaries, we will start by using the subtractive system. You have a bunch of vocabulary words in your Elements and Principles of Design, which you may wish to refer to. Remember that if you can't put your hand on your hard copy, you have a copy of that under Class Resources in Canvas. The most important colors in our system are the primary colors. Primary hues are colors that contain no other hues. We mix these primaries to create all the other colors. Red, yellow, and blue, of course, as I said, are the primaries in the subtractive color system. When two primary colors are mixed in the subtractive system, the results are secondary colors, green, orange, and violet. And you can see here this little Venn diagram that shows that red and yellow mix to create orange, yellow and blue to create green, red and blue to create violet. And you're very likely familiar with these mixing principles from your elementary school use of watercolors and poster paints. When the primaries and secondaries are mixed, we get tertiary colors such as red-orange, yellow-green, etc. And as you can see, the variety of hues between any two colors is infinite. We can organize these colors, and typically they are organized in a circular format that we know as the color wheel. Obviously, this simple color wheel is organized into a series of flat colors. You're also familiar with color wheels that are organized into infinite gradations of colors, like the ones that you may find in your color picker in a paint program, such as Illustrator. A color's place on the color wheel, and that would accord with its place in the rainbow or its place in the spectrum, is called its hue. Hues are placed directly opposite to each other on the color wheel when they're in a relationship that we call complementary. So yellow is a complement of purple, green is a complement of red, blue is a complement of orange. A color's temperature is an aspect of its hue. Color temperature refers to the heat of a color, both in a metaphorical sense, it's physical heat, and also the psychological heat that it gives off. So cool colors are the colors of physical objects that we think of as being cool, like ice and water. Warm hues are the reds, the oranges, the yellows, the colors of flame and glowing stove elements and so forth. Warm hues are vivid in nature. They are bold and energetic. These are all generalizations, of course, but warm colors tend to advance in space. Therefore, you need to take caution so that you don't overwhelm your content with eye-catching warm hues. If an element in your design needs to pop out, consider using warm colors to do that. Cool colors tend to be soothing in nature, to give an impression of calm. They rarely overpower the main content or message of a design. They tend to recede. Therefore, if some element of your design needs to be in the background, you might consider giving it cool tones. Hue is the aspect of color most familiar to the layperson, the one that you may feel the most comfortable understanding right now as you begin your exploration of color. When you ask someone what color something is, typically they will respond with a hue. They will say it's green or orange or a greenish blue, right? So hue, we can say, is the color of a color. But the hue or the temperature of a color isn't enough to capture all the infinite variations of color. We need 3 dimensions to perfectly pinpoint any possible color. Those 3 dimensions are hue, value, and saturation. Value, of course, is the tone created by mixing black and white into shades of gray. The value or tone of an element can create mass, depth, emphasis, volume, and imply light or shade. A color's value is simply its position on the grayscale, the amount of light that it reflects back to the viewer's eye. Every color has a value, but this aspect of color is the most difficult, I believe, to see with the naked eye, because we can't turn off the structures in our eye that view color. The rods, which view value, and the cones, which view color, respond to different light levels. So we can sometimes sense what the value of a color is by squinting at it through our closed eyelashes or by looking at it in a very low light situation. In that situation, you will see the world almost as if it were in black and white. And you can prove that by how difficult it is to match your socks if you get dressed in the dark. Some images read well in value only without any hue or saturation to give us clues, but often changing an image from full color to simply reading in value really changes its mood, right? Finally, our third aspect is saturation. Saturation is the aspect of a color shown by its position on a scale between spectral purity and neutral gray. A color's saturation or purity can be lowered in our subtractive system by mixing in its complement, also by mixing in white, black, or gray. A saturation wheel shows 2 dimensions of color. It shows the hue, in other words, the rainbow position of the color on the outside of the wheel, and then as the colors move in towards the center, they get grayer and grayer and grayer until you get into achromatic grays in the very center. You have to have a 3rd dimension in order to show all the aspects of color. So you can't really show everything about color on a wheel. You have to have a solid. So here we can say if we take the saturation wheel and stack them up so that the one we just looked at here would be in about the center of the stack, where a middle gray is achieved in the middle of the disc. As you go down, the colors would all get darker, and as you go up, the colors would all get lighter in value. Many, many color solids have been constructed by color theorists who are trying to come up with a perfect way of describing every color that could possibly exist in theory. You'll see this on your screens because screens, of course, are 2-dimensional. We can't show a color solid, at least not without some kind of a 3D program where we can turn it in space. But we can easily show 3 dimensions of color by juxtaposing, say, a disk and a slider, which is how it's done in Illustrator, so that you first choose your hue in one place in the color picker, and then you choose your value and saturation in another place. In real life, we don't always use every color because designers do tend to set rules for themselves. We're back to our old unity-variety dialectic. You can easily think about, for example, how you tend to get dressed when you go to school in the morning. Are you a person who likes to wear all black? Are you a person who likes to choose 2 or 3 muted colors and combine them? There are a few people that I've known, some very colorful people, who love to make sure that they're wearing every single color of the rainbow when they go out. But there aren't very many. Most people instinctively have a preference for limited palettes. And we're going to look at some limited palettes and see how artists and designers use those. You're going to be using a limited palette in your next assignment. So triadic color harmonies, that's the first thing that we'll look at here. We call colors harmonies if they are spaced apart on the color wheel, much as musical notes are spaced apart, say on a piano keyboard, so that they achieve chords. This is a metaphor, and you may like it or not, but the idea is that in music you space through 3 or 4 notes to create a harmonious sound which is distinctive from other groupings or intervals of musical notes. Each color chord, if this metaphor works for you, will have a different quality of harmony, just like a musical chord would have a different quality of sound. So we could say that a color chord unites seemingly unrelated hues to produce a color harmony. So the triadic color harmony is based on a triangle inscribed in the color circle for selecting hues. Primary colors, for example, would be a triadic harmony. Secondary colors would be a triadic harmony. Usually when we talk about triads, we talk about an equilateral triangle where the 3 points of it are as far apart as possible on the color wheel. And the square at the right here shows a harmony that is based on the tints, shades, and tones of the secondary colors as a triadic color harmony. So if you refer to your elements and principles of design and color, you'll find that when you add white to a color, the result is called a tint. When you add black, the result is called a shade. And when you add gray, we call that a tone of the color. Triadic palettes give a quick impression of full, vibrant color, though they are in fact very limited. They always kind of remind me of Superman comics for some reason, but for an obvious reason. But you don't get the feeling when you look at triadic harmony of austerity or of careful rule following, right? You get a more generous feeling of rich color. The triadic harmonies of the secondary colors always remind me of the garden. This is a nice example of that in graphic design. Again, this does not give you the impression of a very austere and cautious use of color. It seems generous and full-bodied, and yet it is quite limited. So this is a way that we can combine unity and variety in design, right? Analogous color harmonies are a different triangle in the color wheel. They're a sort of a pie wedge, a section of the color wheel that can go simply along the outside edge, or it can go all the way to the center where we would find neutral gray if this were a saturation disc like the one I showed you before. So analogous colors are a palette or scheme of compatible color combinations that blend well together because they are neighbors on the color wheel. So you can imagine starting with green, adding a little bit of blue to it to get a bluish green, adding a little bit of yellow to get a yellowish green, starting with yellow-orange, bringing it all the way to orange or all the way to yellow. These colors would be related and would give a feeling of unity to a design using them to create the color harmony. Analogous color schemes not only give us unity, but give us a great feeling of variety within the unity. So that you can see as you look at these, not only do they give a strong feeling of temperature and of impact and a feeling of meaningful, deliberate design, but they also give us a possibly at least a great range of, particularly in this one on the left, of value and saturation, as well as some range of hue. Complementary color harmonies are composed of colors that are opposite to each other on the color wheel. In complementary color harmonies, each pairing will always have a primary and a secondary. The complementary pairs are chromatically balanced because each pair contains all 3 primaries. In other words, if one of your primaries is yellow and its opposite is purple, purple is composed of red and blue and therefore gives you that rich feeling that all 3 primaries have been used. When complementary colors are used in design, they tend to have great impact. They don't give quite the the immediate feeling of fullness and variety that analogous or triadic schemes would give, but obviously the trade-off is that they have more impact, more of a feeling of intention. When complementary color schemes are used in painting, they typically aren't quite as rigorous as they might be in a poster or so forth. The Van Gogh painting that you see here is based, of course, on the complementary colors yellow-orange and blue-purple, and you see that within those two complements, Van Gogh has felt free to push the variation just a little bit, which gives the painting a great feeling of richness and fullness, even though it is quite limited in its palette. And similarly, in this Piero della Francesca, Legend of the True Cross, is one of his Arezzo paintings, which I hope you get to see when you're in Italy sometime. You see a sort of a flickering change from these blue-greens to these orange-reds as you cross the painting in a very, very satisfying way. He keeps our eye moving by drawing us again and again through these color harmonies. Some of his blue-greens may go all the way to green, some of them are a little bit bluer, some of the orange-reds are so pale that they're almost pink, and some are so dark that they're almost a sort of a cranberry or maroon, but they're all basically contained within a complementary color scheme. We also have a physiological relationship with complementary contrast, which makes it very, very satisfying to use for viewers. When our eye becomes tired or saturated with one hue, our eye spontaneously produces its visual opposite or complement. This phenomenon is called an afterimage, and the idea is that if you look at an image like this long enough where you see these red and green stripes absolutely vibrating against each other, you should be experiencing those complements on your eyelid when you shut your eyes. Try it and see. I'm not sure how long you'll have to look. This is a very well-known example of that phenomenon, where if you keep staring at the little white dot in the center here for about 30 seconds and then look away at some white or uninflected surface, and you should see the complementary colors of the American flag produced by your brain.